We all love ice creams, candies, desserts, and all other sugary treats that come to mind. Sugar is essential in the food industry as it's used in multiple ways. Added sugar in food is a preservative, sweetener, texture enhancer, and coloring and flavoring agent. Sugarcane and sugar beets are the two primary natural sources of sugar. Around 8000 BC, the indigenous people of New Guinea were the first to domesticate sugar, making it one of the oldest products in existence. Due to the high value of sugar, it was usually held in vaults. In 1751, the first sugar cane plantation in the United States took place in Louisiana, marking the beginning of the sugar business in the country, which presently employs 142,000 people across 22 states. The production of sugar is carried out in around 120 countries each. The harvesting of sugarcane and sugar beets is the first step in the manufacture of sugar. Let's have a look at the harvesting process for both sugarcane and sugar beets. Sugarcane accounts for 80% of the total sugar produced, while sugar beets are responsible for the remaining fraction. Now let's analyze the processes of sugar production one by one. Mechanized harvesters travel around the fields of cane and cut the stalks of sugarcane into short pieces. The harvesters remove the leafy tops of the stalks. These short pieces are also referred to as billets. Bins that are pulled along with the harvester are filled with billets. Once the bins are full, they are transported to the sugar factory via road or railway. Once they are complete, they are placed onto trucks and transported to the factory for processing. The plant materials that have been gathered are sieved regularly to remove any dirt and pebbles. The fall and winter months are the times of year when sugar beets are harvested. During the harvesting process, a rotor beater removes the beet's head and leaves it in the field. The beets are then taken from the ground by a beet loader and placed into a truck, which then carries them to a processing facility. During the subsequent stage of the sugar production process, the raw materials that have been obtained from the fields are first cleaned, and then they are crushed or sliced to facilitate the extraction process. As soon as the sugarcane or sugar beets are delivered to the facility, they are subjected to a comprehensive cleaning operation. Depending on the circumstances, washing may take place in flumes that are filled with water or on belts that are sprayed with water in washing booths. Spinning drums are frequently utilized. The drum is filled with water, and when the product spins inside of it, the product rubs against itself to remove the dirt. The sugarcane or sugar beets are transported to the mill using screws or belts after being washed. The sugarcane is crushed using swing hammer crushers or rollers with deep grooves. To cut sugar beets into cassettes, slicing machines are utilized. The strips that are produced by these machines are of a size that is comparable to that of French fries. Where the cassettes are washed in hot water tanks, the crushed sugarcane is sprayed with hot water and sprinkled liberally. Both approaches involve the expansion of plant cells to get them ready for extraction. A further step involves extracting juice from the broken sugarcane and strips of sugar beets. It is essential to first extract the juice from the sugar plants effectively before sending it to the factory for purification. Some vessels are between 10 and 12 meters tall. The bottles of these vessels are pumped for sugar cassettes as the sugar is extracted. At the same time, the strips of sugar beets are propelled upward by a spinning shaft in the center, which is in opposition to the current of water traveling downward. One of the steps involved in obtaining juice from sugarcane is the process of milling. The bagasse, which can be used as fuel in the future, is separated from the juice by a series of 5 mills that compress the sugarcane fibers. The juice obtained is dark green, acidic, and murky in texture. Large containers are used to collect the juice, and the amount of sugar is then calculated. The cane juice is filtered and made lighter in color using tall towers with a height of up to 20 meters. At the top of the building, the juice is added, and at the bottom, sulfur dioxide vapor is poured in. Sulfitation, a process, causes sulfur dioxide to climb upward through the tower. For every million pounds of juice, in addition to the addition of 120 to 200 pounds of gas, the soluble, non-sugar components are further removed from the sugar cane juice through the use of carbonation or alkalization. Before being combined with milk of lime, a solution of calcium hydroxide, the juice is heated to degrade the protein content. This is done to diminish the alkalinity of the mixture and precipitate the carbonation sludge, which is then filtered to eliminate any impurities from the juice. There is also the possibility of adding carbon dioxide gas bubbles. In most cases, clarifying takes a significant amount of time. After the process, the juice is extracted from the top of the tank, and the sludge is extracted from the bottom. Consequently, mud is generated, which may be utilized as high-quality manure for fertilization in future fields. After that, a line of vacuum evaporators is used to boil the clarified juice until it has a sugar content of 50 to 65%. A thick, practically colorless sugar syrup is created by utilizing paddle skimmers to remove sediment from the head of the evaporators. The next step in the production of sugar is crystallization. In this stage of production, the syrup is evaporated in a single-stage vacuum pan until it's loaded with sugar crystals, which are created via a procedure known as seeding. The seed is gently incorporated into the syrup as a milky suspension of pure sucrose soaked in ethanol and glycerin. The sugar in the solution is broken down into tiny grains that act as nuclei to attract out the sugar and form crystals. After the mixture is brought to a boil in a vacuum pan, a thick paste consisting of sugar crystals and syrup is formed. As the water evaporates and the sugar crystals continue to develop in a large vessel known as a crystallizer, the mixture is then gently agitated and cooled to complete the crystallization process. After crystallization, the next step in manufacturing sugar is called centrifugation. In this process, the content is spun very quickly, and then the substances get separated according to size and density. During the process of centrifugation, the massiquate is put into a high-speed centrifuge, separating it into sugar crystals and molasses. The cylindrical perforated metal basket of the centrifuge, which rotates at 1,000 to 2,800 revolutions per minute, is inside. During the centrifugation process, molasses travels through the coated centrifuge basket and is drawn to the centrifuge's outside. Once it reaches the outside, it is removed and transferred to storage tanks. During the centrifugation process, the sugar is kept trapped inside the enclosed centrifuge basket. The crystals are kept clean by being washed with spring water. The final steps in the production of sugar are drying and packaging. The wet sugar crystals are dehydrated in sizable hot air dryers to as little as 0.02% water content. The sugar is then gently swirled in a granulator through the warm air. The dried crystals are then divided into different sizes using vibrating screens before being placed in storage containers. Eventually, the sugar is packaged for the buyer. Now, do you see the amount of work that goes behind the making of the sugar crystals that you put in your coffee every morning? From harvesting to packaging, sugar production is a vast process. Sugar is a valuable and essential food ingredient with many properties. It not only imparts sweetness and adds flavor to food, but it also gives it scent, color, and texture. So this is the end of today's video. Do you like it? Kindly give your valuable response in our comment section below, and remember to subscribe to our YouTube channel for more exciting and informative videos.